In this video, we're going to be looking at permutations. And so let's go ahead and get started. First of all, let's start with this introduction to permutations. It says, in how many ways can 5 students be lined up? Well, we can use the fundamental counting principle that we learned in section 11.1. Basically, we're making 5 choices, and we're going to find out how many ways we can make each of our choices. Well, if you have 5 students, we're assuming these are 5 different students. There's 5 to choose from to be the first person in line. Now that one has been picked, there's only 4 left for the second position, and then 3, and then 2, and then 1. And if you multiply that out, you get 120 ways. So there's 120 ways that 5 students can be lined up. And that's just using the fundamental counting principle. So this turns out to be a special type of situation in probability. We call this a permutation. A permutation is an ordered arrangement of a given set of items. In this case, our items are students. The number of permutations of n distinct items, now maybe a better word for distinct might be different. Just like I was saying up here, we have 5 different students or distinct students. So the number of permutations of n distinct items is n factorial, symbolized with n with an exclamation point, where n factorial equals n times n minus 1 times n minus 2, all the way down to 1. So in our case, it would be 5 factorial. And that's just 5 times 4 times 3 times 2 times 1. And so you can actually put this into your calculator. Oops, let me get mine. So 5 factorial, we already know it's 120. We just hit the probability button, the PRB, and choose option 3. And when you hit enter, you get 120. Alright, so now we have some problems to practice with. We're going to be working with factorials. So on number 6, we have 6 factorial, which we could write as 6 times 5 times 4 times 3, all the way down to 1. We're just going to use the calculator here. And really, it's just going to be what we just got with 5 factorial times a 6. But I'll just go ahead and put it in here. So 6 factorial is 720. Now I'm going to do the next problem 2 ways. In fact, I would encourage you to try to do B and C using your calculator, and then I'll show you how you can do it by hand. Alright, so let's go ahead and look at this. So 6 factorial over 4 factorial, you should have gotten 30. However, when you did C, basically your calculator had an error. The problem is 100 factorial and 98 factorial are huge numbers. So huge that your calculator can't deal with that many digits. And so here's what we're going to do. Let's go back to B. We could write this as 6 times 5 times 4. Now I could go all the way down to 1, but notice my denominator is 4 factorial. And so we're just going to divide by 4 factorial. And so basically we can cancel the 4 factorials. Now you could multiply that out and just divide by that common factor, but we know 4 factorial here is the same as it is here. So those cancel, and we're left with 30. So that makes it more easy to deal with problem C. This is 100 times 99 times 98 factorial. Again, we'll stop at the same place that our denominator is in. And this will be over 98 factorial, so we can cancel these two guys, they're the same. And if you multiply that out, you get 9,900. Now basically all we're doing, for example, if you had 10 twelfths, you could write that as 5 times 2 over 6 times 2, and we're just basically canceling these common factors, or the other way to think of it is we're dividing the numerator and denominator by 2. In this problem here, we're dividing the numerator and denominator by this huge number. All right, so you could probably figure out D and E without a calculator, but then also maybe check it with a calculator. All right, so here, of course, this is 2 factorial, and that's just 2 times 1, and so here we get 2. And then here, it'd be 8 factorial over 3 factorial. So we're just simplifying in the parentheses there. That's 8 times 7 times 6 times 5 times 4 times, go ahead and stop at 3 factorial since that's what we have in the denominator. These guys cancel. And if you multiply 8 times 7 times 6 times 5 times 4, you should get 6,720. All right. So let's go ahead and do some problems now. In how many ways can 8 books be arranged in a bookcase? Now we're assuming this is 8 different books. Most people don't have 8 of the same book to put in their bookcase. So we're assuming these are 8 distinct or different books. And so this is just a factorial, 8 factorial. And by the way, order does matter because, you know, if you reorder the books, it's different than what it was when you first started. So there's many, how am I supposed to say this? Since the books are all different, every arrangement is different. We want to see how many there are, and that would be 8 factorial. All right, so you end up with 40,320 ways, which to me, it's like, wow, that many, huh? All right, so why don't you try numbers, really you should be able to do 4 through 7. Just read them carefully. Now be careful when you get to 5, 6, and 7, they're going to be a little bit different. But again, I would go back to the fundamental counting principle. You're going to want to use that. Now number 4, you know, is kind of like number 3, but other than that, you're using the counting principle. And really, even with factorials, it really goes back to the fundamental counting principle. All right, so let's see how you did. So here you have 6 comedians that are going to perform tonight at a local comedy club. And how many ways can the acts be ordered? Well, that's basically 6 different comedians, and order does matter. And so we have 6 factorial ways. And if you, well, actually we did that in A, 2A, that was 720 ways. All right, number 5. In how many ways can 5 students be lined up if Mikey, one of the 5, Mikey, one of the 5 is to be first in line? So we have 5 students that we're going to line up. Now, it's really careful that you read these carefully because this is a little different than just, you know, finding 5 factorial. Because for the first position to be first in line, we only have one choice. It has to be Mikey. So once we've chosen Mikey, we have 4 people to choose from for the second position, and then 3 for the third, and so on. And so really, you could just multiply this out, or you could even think of this as 4 factorial. But this is 4 times 3, which is 12, times 2, and you get 24 ways. So notice it's not 5 factorial. If you read it too fast, you may have gotten that answer. Let's look at number 6. A president and a vice president are to be chosen from 7 students. Well, that means there's 2 choices being made. And how many ways can this be done? Well, there's 7 students to choose from for president. Now, once a president's been chosen, there's only 6 students left for vice president. And so if you multiply those out, you get 42 ways to choose a president and then a vice president. All right, let's go down to number 7. So again, if you haven't already tried this, I would encourage you to try it first and then watch the video. So here you have 12 players and you're choosing 3, well, 1 to be MVP, 1 to be most improved, and 1 to be team player. Generally speaking, in a case like this, even though we may have 1 amazing player, we don't want to give them all 3 of those. We're going to pick 3 guys. So that's what's going on here. And I realize it's not exactly random, but we're just really finding out how many possible outcomes there are here, or how many different ways this can be done. So to start with, for MVP, we have 12 players to choose from. For most improved, now we've already picked one of the players to be MVP, so that means there's only 11 now to choose from for most improved. And then finally for team player, there's now 10 to choose from. So if you multiply that out, there's 1,320 ways we could do this. All right, let's go ahead and move on to the next page. So again, I would encourage you to do number 7 and then we'll talk about it. No, not number 7, number 8. All right, let's do this. So we have 120 swimmers at a swim meet, and we're going to choose the top 12 or we should say the top 12 swimmers are going to be awarded ribbons from 1st to 12th. So there's 12 people that we're going to choose for ribbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. All right, so there's 120 ways to choose, or that, 120 swimmers that could be awarded the first position. There's 119 now left that could get the second ribbon, second place. And then 118, and we can just keep going down. So this is going to be a pretty big number on your calculator. If you multiply that out, you're going to get something that shows you it's 5.05, and you'll get a lot more places than that, but we're going to round to 2 decimal places, times 10 to the 24th power. So basically, you'd have to move this decimal to the right 24 times to see what that number is. That's a huge, huge number. And so that's the number of ways that this could occur. All right, so I think I'm going to go ahead and stop the video here, and I'll make a second video for the remainder of this lesson.